Hey guys, Mr. Middleton here. Today we're looking at surface area of cylinders notes. At the end of this video, you should be able to find the lateral area and surface area of a cylinder, and you should be able to find the surface area of a composite shape. Okay, a cylinder is very similar to a prism in that there are two parallel bases. The difference is that instead of the bases being polygons, they are circles. Okay. If you were to draw the net of a cylinder, the bases would be circles, and the lateral face, remember that's the face connecting the bases, is a rectangle. Remember from last lesson that the lateral area of a figure is the area of a figure not including the bases. Okay, so everything except for the bases is going to be our lateral area. In a prism, we found the lateral area by doing the perimeter of the base times the height of the prism. Okay, what do we call the perimeter of a circle? It is the circumference. Circumference, right? We dealt with that a lot last chapter. How do we find it? Circumference equals 2 times pi times r, or pi times diameter, however you like to look at that. Okay, therefore, to find the lateral area of a cylinder, saying how similar it is to a prism, we do the exact same thing, except the lateral area is going to be circumference, 2 pi r, times height. Okay, the surface area of a figure includes the bases. Okay, in a prism, the surface area was the lateral area plus 2 bases. Okay, how do we find the area of a circle? Okay, remember that B stands for the area of the base. Area of a circle is pi r squared. Okay, therefore, to find the lateral area of a cylinder, we can use the formula, the surface area, we can use the formula surface area equals lateral area plus 2 times pi r squared. Okay. All right, so let's look at that in action here. This first problem. Okay, so first problem, I'm going to draw the net. Not that you'd have to do that any other time. Just want you to see how this works out. Okay, so a net of a cylinder might look something like this, right? Okay, and as you're thinking about the dimensions of our net, we can see the height is 8. Okay, and you're thinking, hey, this side of our rectangle should wrap around the outside of our circle. Okay, and that's why our perimeter here is our circumference. Okay, we can find the circumference by doing 2 pi r. In this case, our radius is 3. So 2 times 3, 6 times pi. So 6 pi. Okay, so our lateral area equals our circumference, which we just found to be 6 pi, times our height, which is 8. The directions tell us to leave it in terms of pi, so our lateral area is 48 pi units squared. Okay, to find the surface area then, we take our lateral area and add the area of the two circles to it, right? Because up to this point, we found this was 48. So we need to make sure that when we talk about the surface area, we're including these two bases as well. Okay, so to find that, we have our lateral area, which is already 48 pi. Great, we can start there. To find our area of our base, the base is pi r squared. So our radius is 3. So 9 pi, which gives us 18 pi. Okay, so we have 48 pi plus 18 pi, and that is 66 pi units squared. Okay, and that's because we added the two bases to our lateral area. Okay. A lot less variance here because in the cylinder, all of our bases are going to be circles. With prisms, we were dealing with squares and triangles and rectangles and hexagons and octagons, and so a lot less variance here. Next example says a Campbell's soup can is 4 inches wide and 6 inches tall. How many square inches are needed to make the labels of these cans? Okay, so it's important here as we think about this. Okay, the can is 4 inches wide. Make sure I mark that. Can is 6 inches tall. Okay, mark that. Okay, so before we start, it's going to be important for us to understand what we're answering. And for this, it's only asking us about the label. Notice as you look at the can, there's not a label on the top of the can, right? Top of the can stays clear, right? So there's nothing up here. We don't need a label up here. And might not know, but on the bottom of the can, there's not a label, right? Okay, and so what they're saying is we only need to cover the lateral face. So it's just asking us for the lateral area. Okay, so important for us to realize that before we get started. Now that we're thinking that, we have to make sure that we're finding the lateral area. Remember, that is the circumference, 2 pi r, times the height. Okay, they gave us the width of the can being 4 inches, but for our radius, for our circumference, we need the radius. Okay, so our radius is 2 times 2, 4 pi. Our height is 6 inches. Okay, and so our lateral area would be 24 pi inches squared. Okay, now typically in a real world situation, unless somebody asks us to give this to them in pi, we probably want to give them a decimal answer. So let's go for that. 24 pi gives us 75.39, okay, or 75.4 inches squared of paper. That's how much we would need in order to make the labels of the can. Last one here is a composite figure. It says find the surface area of the figure below, given that the top of the figure is half of a cylinder. Okay, so what we have here is a prism and a cylinder kind of mashed together. It's going to be up to us to kind of be able to think outside of a formula, or at least past a formula, because it's not going to just be like, hey, the formula when you have half a cylinder and half a prism is this, right? So we have to think a little bit more critically about how we find all of these surface areas. Okay, so I'm looking at this prism first, right? I'm going to break it down and say, hey, I have a prism. I'm terrible at drawing prisms if you stuck with me any time so far. So I'm just going to try to use it here. I have a prism here with all these sides, but only one base is on the surface, right? The half cylinder covers up that other base. So as I look at that, I need to find the lateral area for the prism, which is going to give me the perimeter of the base. I'm going to call this the base. Perimeter of the base, 84 plus 16 gives me 90. Nope, it's 80. 80. Times the height of the prism, which is 35. So 80 times 35 gives me 2,800. So I see that as the lateral area, 2,800. Okay, I'm going to add to that lateral area the base, because I haven't talked about that. I haven't added that yet. So the base is just a rectangle, base 42 times 8. And that gives me 336. Okay, so when I'm just talking about the prism part of this, I get 3,136 centimeters squared. Okay, that's the prism. We'll make sure I label it for myself so I don't get mixed up with anything. Okay, so now they told us that this is half of a cylinder, so really I can find the surface area of an entire cylinder and then divide it in half, right? Because all this stuff there, we're not losing any bases here, but we are losing exactly half of the cylinder. So as we find it, surface area of a cylinder is going to give us our lateral area plus 2 bases. Then at the end of that, I'm just going to divide it by 2. So our lateral area is the perimeter of this. We see that this is 8, right? And so our radius for that figure should be 4. And that's important for us because we need that for the area of our base and for the circumference. And so for our lateral area, we have that circumference, which is 2 pi r, or 8 pi. The height of our cylinder is 42. Notice that the height of the cylinder is different than the height of the prism. Okay, the height of our cylinder is here. Okay, so times 42. And that gives us what? 336. So our lateral area is 336 pi so far, if it was our entire cylinder, right? Plus 2 area of base is pi r squared. Okay, so that 4 squared, 16 pi. So plus 32 pi. We can add those together. We get 368 pi. That would be the entire cylinder. If this were an entire cylinder, that's what our answer would be. But they told us not an entire cylinder, it's at half. It's half of it. So divided by 2, 368 divided by 2 gives us 184. Okay, so plus 184 pi. Again, because we're dividing this by 2 to make sure it's half. Okay, so 184 pi. This would be our exact answer. If we want to leave it like this, we could say 3,136 plus 184 pi centimeters squared. Okay, but probably want to use this as a decimal, and that should give us 3,714.1 centimeters squared. All right, so there you have it. Finding the surface area, lateral area of a cylinder, and then being able to use our information, our knowledge about prisms and cylinders to find composite figures. All right, see you.